And we are live, you guys. It's Friday. Woohoo! Doesn't feel like Friday, but it is. It is Friday. Okay, so number one, first of all, if you are behind, you need to get caught up, okay? Next week, we'll have a test on Tuesday, and I'll give everybody until Friday to get it done. Now, that's a lot of time to get it done. So that'll be a great time to also get caught up. Plus, this weekend, if you're already caught up and you're doing great, cool. You might just have a couple of days off. Wouldn't that be nice? Okay, homework today. So, if I take a look, what they needed was just the totals. So I got the totals: 218, 220 that aren't going to go to college. I've got 230 males, 208 females. Oh, and I forgot to put this total down here. Let's see, what is that? 438? I think so. Anyway, there it is, right? Same thing on this one. There are 190 males, 182 females. 99 that own a car, 273 that don't own a car. What's the totals? Let's see, 17, carry the 1, 372. Okay, that's the totals, okay? Number 3, what I did is we created a two-way table from the information. This is what the answers are, okay? You want to check that out. On number 3, we're just looking at percentages. So we want the marginal frequencies, so you just take 96 divided by 318 to get that. We're going to take the 80 divided by 318 and we get that. The 54 divided by the 318. And then even on these totals, you're going to take 176 divided by 318, 142 divided by 318. Now, 5 is really confusing, and these are the answers, okay? So it's going to be taking your marginals divided by your joints, and we will not, honestly guys, we will not have this on our test. Okay, next year when I teach this, I won't even bother with this. It's a little confusing for kids that are in Algebra 1. Probably a better thing for maybe kids in Algebra 2. So anyway, if you're totally confused with number 5, I am so sorry. We won't even see that again, okay? Now, let's move on to today's lesson, all right? Now, first of all, today's lesson, 7.5, is going to be looking at different ways to look at statistics. So we're going to look at different graphs and statistics. Okay, what we like about graphs is that they can then give you a picture of what's going on. We've been looking at all these different graphs instead of looking at a bunch of numbers. As an example, you can look at all these numbers here, and what does it mean? A lot of numbers, too many numbers. You got to sort it out. You got to make a picture, okay? All these numbers, what does it mean? You got to make a picture, make it make sense, okay? So what are these numbers? Okay, let's make a picture. Okay, but before we do that, let's talk about these 3 things. Okay, so types of data. Example. Okay, qualitative and quantitative. Qualitative will not have let's just say no numbers. Example. What's your favorite color? What is your favorite color? We could go around and we could interview people and we can get a bunch of data. How many people like yellow? How many? And we'd get numbers that way, but it's really not going to be qualitative where your data actually has numerical value. So qualitative, you have numerical values. Okay, we've been talking about that specifically. Okay, now misleading graph. Okay, let me give you an example. We are stuck in the coronavirus era. It's no fun. It sucks. There are some that are no believers, and I'm not going to get political with you, but there are some that are no believers. Okay, so let me show you what I saw this morning so you get an idea of what a misleading graph could be. Okay, so let me load it up on my phone so you guys can see this. Oh, I might not get it because I'm out in the trailer. Anyway, let's just say right now in Washington State we have, oh gosh, I can't remember what the numbers are. Let's say we've got 5,280 cases, okay, in Washington State, okay? And so then a misleading graph. Let me show you a misleading graph, okay? Let's say we have each day, we've got day 1, day 2, day 3, day 4, right? And a misleading graph could be something like this. This scale might be in terms of 10,000s. 10,000, 20,000, 30,000, 40,000. So 5,000 cases is right down here. But say, let's say day 1 was like that. Day 2, day 3, you know, and we're starting to get less cases. So this, if you look at this graph here, you're like, wow, there's no problem at all. Hardly anybody's getting the virus. But this is a misleading graph because it looks like there's no problem at all. So it just depends. If you want to make your data look any way you can. That's what I don't like about statistics, is that if you're a statistician, you can make your graph look any way you want so that you can present your case any way you want. So politically, some people will make their graphs look a certain way and say, hey, look at this. There's hardly any cases. That's a misleading graph. And there's lots of other examples of misleading graphs, okay? Yeah, my phone's not going to give me the answers. Anyway, we can look it up later. So that would be an example of a misleading graph, okay? So, page 211. Okay, I'm going to go look at that. It says, look at page 211. 211. And why do I have that? Let's check it out. Okay. So there's lots of types of graphs. We can do a bar graph, circle graph, scatter plots, stem leaf, pictograph, a line graph, box and whisker, histograms, or a dot plot. These are all different ways we can show data, okay? Depending what you want. So for us, we can pick and choose any of these as long as it fits. So I've got 3 examples today, and we're going to look at them, okay? Example 1. Since there's only 1, 2, 3, 4, 5 pieces of data, and I want to compare them, I'm going to use the old-fashioned circle or pie graph, okay? You can use a lot of different ones, but I'm going to use a pie graph. A bar graph would also work on this one, but I want to use a pie graph to show you how to do a pie graph. So, to do a pie graph, I drew a circle. I found the center of the circle. Now the total, let's find the total, because we need the total. So I'm going to use my calculator. What is the total? Let's add them up. So I'm going to go, okay, clearly, I'm going to go 307. If I make mistakes, you guys let me know. 227, 20, oops, almost made a mistake. 27, 46, plus 145, plus 75, plus 689, okay? And I get a total of 3,962. That's my total. Now, if I want to do a circle graph, there are 360 degrees in one circle. Now I have a protractor with me, and this protractor goes all the way around, which is very helpful. So what I want to do is this. I'm going to find out what percentage. So I'm going to take birds first. There's 307 out of 3,962 birds. Now I'm going to get a percentage, so I take my calculator and I'm going to divide 307 by 3,962, and I get a decimal. Now that's like 7%. So I'm going to now multiply that number times 360 because I want to know what angle, how much of this circle represents the bird. So I got my percentage, about 0.77%. I'm going to multiply that number by 360. Okay, so I got an angle of about 28.9. So we can round it up about 28 degrees. Okay. So here's how it works. So I'm going to go ahead and put birds in here. I need a 28 degree angle. If we were in class, I'd have you do this. Okay, there's my 28 degrees. Okay, I'll do it again. Zero it out. 10, 20, 28 is about there. So I draw a line from there to there. Now, we're going to label this. We're going to put birds. 28%. 28 degrees, which is, actually I wanted the percentage, which is 7.7%. I want that. I want 7.7%. Okay, not degree, 7.7%. There we go. Now the next one I could do is the mammals. The same thing. I'll take my 2,746 and I'll divide it by my total, 3,962, and then I'll multiply that answer times 360 to get an angle. So first, what is 2,746 divided by 3,962? That's about a 69%, okay? Okay, now I'm going to multiply that times my 360, and I can answer about 259.5 degrees. 259.5 degrees. So, take my circle, and I have to start from where I left off on the birds. So now 259-degree angle is huge, right? Luckily I got this gigantic protractor. So I'm going to go 10, 20, 30, 40, 90, 100, 120, I get 180. I'm looking for 259. 259 is all the way over here. It's a big angle. 259 is right about there, okay? So it's all of this. Right? There is my mammals. And what percentage was that? It was about 69%. Yeah, most poor animals killed on the road are probably going to be mammals. Now, amphibians, we'll do the same thing with amphibians. We'll take their total, 145, divided by the total of 3,962. Multiply that by 360 degrees. Alright, so I'll do that. 145 divided by 3,962, and I get about 3.5%, not much. Multiply that times 360, and I get about 13 degrees, okay? So percentage-wise, about 3.6%. So again, I'm going to take off for what I left off on the mammals, and I'm going to try and draw a 13 degree, 13 points, about 18 degrees, about 10, 20, 18 degrees might be right about there. I'm going to draw my, okay, 18 degrees right about there. Okay, and that's going to be my amphibians, and they were about 3.6%. Okay, and then reptiles are going to be even smaller. So reptiles, I'll do, well, I'm running out of room, but I'll do it here. Reptiles, I can take my 75 and divide it by my 3,962 times my 360 degrees. Okay, so 75 divided by 3,962, about 2%, pretty low. Okay, times 360, and I only get about 6.8 degrees, pretty little. So 6.8 degrees, go zeroed out again. See, zeroed out 6.8 degrees, only about right about here. Draw in my little bar graph. So there's my reptiles. I'll put reps, and they were, what was my percentage? About 2%. Now obviously the rest is unknown. I put unknown. I don't know why I put unknown. That's crazy. How do you know what kind of animal it is or isn't? But I'm not sure. But if I need to know the percentage, I'm going to take that and divide it by my 3,962. So 689 divided by 3,962, and I get it about 17%. Now, what makes these really nice, if you color them, I always like to color them because it makes it look pretty. So we make birds blue, you know, make it look nice. Okay, and of course then I make this one orange, color it in, make it look beautiful because I like it to look nice. Elena will make hers look beautiful, I know that. And then I might use, let's see, I got a green for unknown. Again, this is my job. I know some of you will do a much better job. Oh, I got a red for maybe amphibians, and maybe I'll leave reptiles as white. Anyway, that is a pie graph, and that's how it's done. And you look at that, and you get an obvious. You're like, whoa, most of the animals killed are mammals, and I like to put the percentage. It helps a lot. Okay, that is a pie graph. You have to do it out of 360 degrees. You get your percentages, dividing the number by the total, multiply that percentage, or that decimal, by 360. Okay, moving on. Okay, now this data shows the number of black bears killed on a state road from 93 to 2012. Okay, so this one I'm going to try a broken line graph. So I'm going to get a piece of graph paper and let's see what I can do. So I'm going to try, and I've got, looks like quite a few years. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so I got 20 years, and I go to the highest height is 135. So I got a ruler out, and I got to make sure I label everything really nicely. Okay, so I'm going to go ahead and make my graph here. My scales. Let's see. Okay, there's that. And that. And the very first year I got any information was 1993. 1993, 94, 95, 96, 97, 98, 99, 100, 100, which is obviously going to be year 2000. Funny. 2001, 01, 02, 03, 04, 05. How far do I go? 12, really, 5. 06, 07, 08, 09, 10, 11, and 12. 2000, right? So the 2000s. And now the highest I go is 135. So I'm thinking maybe if I go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130. Here's my 130. 20, 30, 40, 50, 60, 70, 80. I missed 110, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. I'm okay. 120, 130. And so if I label this years, and this is number of black bear, this is population. I don't want population. We'll say number. We'll say number. Number killed. Oh, what a sad thing. Okay. And so I like give a title. We can say number of black bears killed on highway, right? So you guys, we're gonna make it much nicer than this. But a broken line graph, and I won't do all of it because you guys know how to do this. You just do dot to dot. 1993 was 30 of them, so put a dot right there. 37, see I'm doing this, and then 46, about there. 33 is about there. 43, 1997, 43, right? 35. So the question is, why is this happening? Why are there more and more? Probably because this is a area like Leavenworth. More and more people keep coming to live in our community, and with more and more people, there's more and more cars on the roads, and poor bears don't have a chance, right? Anyway, that's a broken line graph, and you can connect the dots if you want to. Okay, so it looks like a broken line, and then you keep going and going and going. Okay, got it? Pretty easy. Okay, now example 3. Here's a bunch of data, right? And they want us to do a box and whisker plot. So, again, if you have a decent calculator, or even on your phone, and you go and you find your stat on your phone, I put this into my calculator. I like this button here. If I put it in, I can get the mean, median, mode, and range. There's some calculators that even do quarter 1, quarter 2. So I don't need you guys to do everything by hand, but if I went to, for instance, stat on my calculator and put them all in, for me it's not that bad. 13.4, enter, 15.2. I'll show you what my calculator does. 14.2. And there are apps that you can get on your phone that will make this so much easier. 14.8, enter, 18.7, enter, 9.5, enter, 13.6, enter, 17. If I make a mistake, you guys let me know. You guys are always good about that. Thank you. 25.5, 9.4, enter. 17.5, enter. 12.9, 17.2, 21.5, 18.5. I want to show you this because my calculator does some cool things. I should have entered this earlier to save time, but that's okay. It doesn't matter. Gives you time to get caught up. 17.3, 21.5, 21.5 again, 9.4, 19.1, 14, enter. 16.8, 19.4, 11, 13.9, enter. 14.8, enter. 15.7, enter. 12.4, enter, and 19. Okay, now watch this. So my calculator does a lot of cool things. And again, if you want to get your phone and find a cool app that'll do it, and you might, there's tons of stats apps. So what mine will do, I'll go back to stat, calculate, one variable, because that's all I'm doing is one variable stat, to calculate. I'll get everything I need. So here's what I have. I've got the standard deviation. I don't need that. I've got the mean. I don't need that. But what I do want for box and whisker is these. Okay, I got my minimum. So now my minimum for my calculator is a 9.4. I got my quarter 1 is 13.95. Q1 is 13.95. I got my median is at 17.1. Oh my God, my quarter 3 is at 19.05. My last endpoint is at 25.4. So now I didn't have to do a whole lot of work. Let the calculator do it for me. So then if I make my number line, right, for box and whisker, and let's see, let's make this be 10 and go 15, 20, 25. Okay, we could have made bigger spaces if we wanted to, but now for my box and whisker, here we go. We're going to put a 9.5, we'll put a whisker end, and at 25.4 we'll put a whisker end. We'll put my quarter 1 is at 13.9, is about there. We'll put my quarter 3 is at 19, is about there. Okay, connect my dots for my whisker, and then my median's about 17.1, maybe right about there. Okay, got it all. Anyway, there we go. So hopefully you guys saw some things. If you don't have a decent way to get these things, go and get an app. I got an app here. It gives range, mean, median, mode, standard deviation. This one does not give quarter 1, quarter 2, but my guess is there are apps out there that will, because you don't want to do it the long way. So homework today, let's go through it. I'm going to do page 213. Okay. On the first 4, is it qualitative or quantitative? With the T, quantitative, we need numbers. Qualitative, it's no numbers, just, you know, do I like it or not like it, okay? 5, make a box and whisker. That's what the book wants. 2 different box and whiskers to compare them. Number 6, stem and leaf. Okay, so you know how to do stem and leaf. Stem and leaf is like this, okay? And you're going to put a little key. Your little key is that, say 5/4 is 54. For stem and leaf, let's see, the smallest is 3. So 3, and then this would be a 33, 4, and you have 4, 0, and another 0, and of course stem and leaf, so I'll have you do a stem and leaf. And then 7 and 8 is just to interpret what kind of graph you have and explain why it might be misleading. Okay, that's it.